everyone, let's solve this problem. Word break. Given a string s and a dictionary of strings verdict, return true if s can be segmented into a space separated sequence of one or more dictionary words. Note that same word in the dictionary may be reused multiple times in the segmentation. So we are given a couple of examples. In this case, for the first example, we have given LeetCode as a string, and the breakage of that string, leet and code are present in the word dictionary. And same thing with the second example, and third example is that it is not present. So we are going to solve it using DP. Let's understand how we can do that. So this is the example we have, and so as we will be checking this at the end. When there is an empty string, it is always true, so I will be marking it as true. So our DP length would be s.length plus 1. Okay, and now we will check. We are going to take one character, but do we have any word with one character? No, so this is going to be false. And then same thing, two characters, there are no words, so it is going to be false. And with three characters, let's check. Dog is not cats is not of length 3 characters, so we will go to the next word. We got dog matching, so in this case the word is present. We will mark it as true and we will continue. We don't have to go forward because we found one of the words matching. Now again at n, the possible strings are 4 letters or 3 letters. If you see here, 4 letters, these 4 letters does not match. 3 letters, these 3 letters does not match. Sand, 4 letters does not match. 3 letters does not match. And cat, 3 letters does not match with this, so we will mark it as false. And then we are going to again check for a substring starting with a and of length 4 and 3. So of length 3, so first word is of length 4, so let's check. 4 letter word, it's not possible. And 3 letter word D, it's possible but it is not equal. Then we will move for 4 letter word again, and this is not matching with sand, so we will ignore it. And 3 letter word, it's matching and also is equal. So whenever it is equal, what will we do is I plus word.length. Word.length is 3 here, and I is, okay, let me know, word.length, and I here is 4 and word.length is 3. If you see, 4 plus 3 is 7, but it's a false here, so we do not have a word. I cannot take this word, and OG is not present as a single word, so it is going to be false. And then I'm going to go to S. So we are going to compare 4 characters with cats, it's not same. Then 3 characters with dog, it's not same. Then 4 with this 4 characters, they are same. Now what am I going to check is I is 3 and word length is 4, 7. If you see the index at 7, it is false, the value is false. That means again it's the same case where I cannot break into sand and OG, so that is the reason it is going to be false. And then we will take the 3 letter word SAN and they are not matching, and then cat, SAN and cat, they are not matching, so we will go forward. And now I am at T, so we have to take again 4 letter word. This is not matching with cat. Then 3 letter word dog, not matching. And then 4 letter word sand, not matching. So basically I am taking the length of the substring based on the words, like I am iterating over all the words, and according to the length of the word I am taking the substring in the S. This is the S string. So So basically no word matches in this, so this is going to be false. And A, again if you see in the entire words list, there is no word starting with like A and TS. So there is only one word starting with A, but it does not match, so we can easily mark it as false instead of like iterating over there. And now C, when I get C, I will check the 4-letter word first, because the letters in the first word is 4. Cats, it's matching, so when it is matching, I am at 0 index, and length is 4. But if you see at the index 4, it's false, so it will be false. And then I'm going to check further, like 3-letter word cat and dog are not matching, 4-letter word cats and sand is not matching, 3-letter word cat and is not matching, and then cat and cat, they are matching, but again 0 plus 3 index, if you go here it is false, so it will be again false. Now let's take one more example of LeetCode. So in this case it will be true initially, and E, there will be like there are only words of 4 length, so I cannot take this, I cannot take this, I cannot take this. At this particular length the word can be of length 4, so it's not matching with lit, but it is matching with code. So I will just mark it as again 4 plus length of the code 4, 8. At 8 the value is true, so I will be marking it as true. Then again I will be starting at the index 3. I will check 4-letter words. This is not possible, they are not matching to any of the words in the string, so it will be false. And then again I am at E. Again I'll create a word of 4 characters. This is not matching with any of this, so I can directly mention false. Same thing here, I have a 4-letter word of EETC, but it is not matching with any of them, so I'll mark it as false. Now at this position L, I have a word of 4 characters LEET, which is matching with the first word, and I have to check 0 plus length of the word is 4. So if I check at the 4th length, we already have a word from 4 till the end, so I am sure that there is a word, like I can mark it as complete because there was already a word from 4 till the end, right? So this is how we are going to do it. Now let's try to code it up. So we are going to initially declare our dp array length plus 1 as we discussed, and we are going to mark all of them false initially, and dp of the last index would be marked as true because that is going to be a empty string. Then we are going to iterate from the end, and also we are going to iterate over all the words. At any given index, I'm going to check if i plus word.length is less than or equal to s.length. That is when I'll be taking it as a, like for example, if I am at E, I is 7 plus word length here are 4 most probably, so 7 plus 4 will always be greater than like the string length, so we are not going to take this index. Same thing here, right? We are not going to take these indexes, so directly we can eliminate them. And if they are falling within the limits, then what am I going to do is s.slice. I'm going to check the substring is equal to word or not. If they are equal, then I'm going to mark dp of I is equals to dp of I plus word.length as we discussed. If I have at this position, when I was updating my value, I was checking index plus word dot length. That was nothing but 0 plus 4. There was a possibility of the word from fourth index till the end. That's the reason I'm marking it as true. So I'll mark it as true. And if I have found a word which can be possible from index I to index I plus word dot length, then I can break this condition. I don't have to check for the further words. And after that our answer will be in the dp of 0, because at dp of 0 we are considering the entire string, and we are checking if from index 0 till the end is it possible for us to break them into words which are present in the word dictionary. So it is true in this case. So now let's try to run it, submit it. Okay, code is accepted. Now let's try to understand the time complexity and also the space complexity. Space complexity is pretty simple. It is big O of n, because we are using the dp array, and n is nothing but length of s. And in case of time complexity, it is n, because this loop we are iterating over n elements and we are iterating over all the words. So let's consider number of words as m, right? And then we are also comparing, like we are matching the substring with the word, so it will take some w time, considering w as the max length of word in the dictionary, right? So it will be m into n into m into w. So that is the time complexity, and space complexity is big O of n. I hope the solution is clear. Thank you.